Okay, let's explore a few more options, okay, about this dynamic mesh motion. So what we look at now is about the multi body movement. Okay, so let's say there is a multiple body and at a time two body is moving or rotating anything. Okay, so let's explore with the help of this very simple tutorial. Okay, it is about the two cylinder is moving at a time. So let's first explore the entire tutorial, then we try to look at few aspect here. So first let's go to the folder, create the environment. So we are working with the extended version 4 for this tutorial. Okay, so now let's first clean the test case. Let's say block mesh. Okay, check how the mesh look like. Okay, so look, we have a two cylinder. Okay, and it is located something like this way. So if you look at, this is one cell zone, another cell zone, and there is a interface in between. Look here, as well as here also we have interface in between. So let's explore few things. So we have inlet. So this is inlet portion. Okay, then we have an outlet portion here. So that is what we have, inlet outlet. In between, then we have a top bottom inlet outlet. Okay, so this is very straightforward rectangular box. Within this we have a couple of few more entries like cylinder, first cylinder. Okay, then second cylinder. This is the two cylinder boundary. Then front in, that is this part. Okay, front out. Okay, so front in, front out, then middle in, middle out. So this is middle in, middle out, both the places, and then back in, back out. Okay, so that is the three interface. So here we have a in and out, in and out, in and out. Okay, so that is what we have, and default patch is empty, that is this one. Okay, so first cell thick we are looking at. So this is the our computational domain, and we going to specify certain movement to this both the cylinders. Okay, so that is the idea behind that. Okay, so for that we have to use certain bash files. So let's look at the bash file. So what we required the zones, phase zones, that is attached to all the four interface. Okay, so that is what we're going to create with the help of this bash file. So that is what we are dealing with. Okay, so that is done now. Okay, anyway, log file is not going to generate, so no worry. Then we have a set bash motion, one another file. Okay, so what it going to do, it try to generate couple of the cell zones. Okay, that is required and facilitate the our cell motion. So that is what we're going to do. Before that, let me quickly show you what we just now constructed sets. Okay, so this is the sets we have. Okay, so all the sets what we have at present. Okay, so let's look at the sets here. Okay, so we have all these sets, because it's already generated, so a couple of sets is available inside. Okay, so let's explore. Okay, I suggest something like this way. Let first create the entire mesh. Okay, then we try to look at again. Okay, the same thing. So I'm going to do same thing again. Okay, because I want to clean first the case. Okay, fine, sorry, save. So we clean it, so we don't have anything right now. Okay, so let's start again. So let's say block mesh. After the block mesh, if you see, we have all this thing as well as all the sets. Okay, so these sets we constructed within the block mesh itself. Okay, so if you open it, you will come to know all the sets. So from this we constructed the cell 1, cell cylinder 1, then cylinder top bottom, cylinder 2, cylinder 2 top bottom, all these things we constructed. So let's first look at how exactly it's looked like. Okay, so we have an idea what we are doing. Let's include the sets. Okay, now switch off this, so we understand all the boundary file. Now just look at what is cylinder top and bottom. Okay, so this is the cylinder top and bottom file, and cylinder is located in between. Okay, so this is the cylinder located, and top and bottom portion is what we are looking at. That means if you look at this, so this is the top and bottom portion, so this portion and this portion is that part. Okay, so let me switch off that. Okay, so cylinder top bottom, then cylinder 2 top and bottom. Okay, so that is top and bottom. Then we have a cylinder cell, that is exactly where the cylinder is lying. Cylinder cell 1, cylinder cell 2. Okay, so this is that many sets we constructed from the block mesh files. Okay, and everything available at the set level. So that many 6 available. That means 1, 2, 3, 4, 5 and 6. Okay, so that many blocks is a cell sets 1, 2, 3, 4, 5, 6. Okay, so that is total sets we have. Okay, now what we do now, we use this for set batch GGI. Okay, so here we are constructing few phase zones to exchange the data, to facilitate data exchange for the GGI point of view. Okay, so let's first run that particular command and then come back again here. Okay, so let's do that. Okay, so after that, if you see, we have a few more phase zones that is attached with all the boundaries. So again, go back and check what is that phase zone all is about. So let's say sets. Okay, so this is what we have, all the phase sets whatever we constructed. Okay, so this is where we have all the sets that is facilitate the data exchange. Okay, so that is what we required. Wherever we have interface, we are constructing the file sets. Okay, so that is what we have. Then just look at the set bash motions. Okay, so what we require the certain few more phase sets. Okay, so top layer cylinder 1, that is one sets we want to construct. Okay, so first we try to run this file and then check all the sets again. Okay, so let's look at execute this. Okay, and then we have a couple of few more sets here. Okay, so let's check what we constructed, apply, and all the sets. Okay, so we have so many sets. Okay, so look, top layer sets. Okay, we have. Okay, so this is the top layer as a sets. Why it required within this layer, we want to increase or decrease the cell layers. Okay, so let me open the constant dynamic files. Okay, so look, this is top layer cell 1 and bottom layer cell 1 that is required for layer faces. Okay, so this is the what we required. Sorry, from here, this one, top layer faces, and the so this is what we have. Okay, as well as this one, and this one. Okay, so this is all we have. Okay, this is old, delete that. Okay, and again this is old, so delete that. Okay, so this is what moving patch whatever we have, it is this, that is top. Same way we have a bottom layer. Okay, this is master. Okay, so from that we're going to generate these layers. Okay, so this is what we required, top layer cylinder 1, bottom layer cylinder 1. Okay, so top layer cylinder 1, then we just have to figure it out where is the bottom layer cylinder 1. Okay, yeah, it is there only. Okay, so here bottom layer cylinder 1. Okay, this is face sets we have. So let me close this. So similar line we have that one. Okay, so for cylinder 1 and cylinder 2 that is required, so that is what we are using for layering the mesh. Okay, so that is we constructed with this particular bash files. Okay, so all this required to generate these layers. Okay, and then based on that layer we able to add and remove the layers. Okay, so let quickly check the dynamic mesh files. So what we have a first cylinder and the second cylinder. For first cylinder, cell 1 is the moving zone and this is their layers. Okay, and the motion is the linear oscillatory motion we're going to use, solid body amplitude, and in the y direction we are allowing the cylinder to move. Okay, and while it is moving, what is the minimum and maximum thickness of the layer it's supposed to take into account, that is what we are specifying. Same way for the back cylinder, cell zone that is moving is cylinder 2, and this is the layers within which the it try to add up the layers with the help of these phase zones. Okay, and then we have a linear oscillatory motions in the particular direction. So this is positive, that is going in the up, this is negative going in the down way. Okay, so that is what we have. And then again the thickness. So this is how you can set the motions for the multiple cylinders. Okay, so this all sets and everything is required because we are developing the mesh from our own block mesh. Okay, let's say you already have a mesh, okay, and you generate the mesh with the help of the ICM or any other thing, then this all things is not required. Then straight away we can add up the few things, like if you have proper name to that, all the cell zones and everything. Okay, phase zone from the extra measure, then this set bash motions file need not to run. Okay, so that is the what I am mean to say. Now let's first look at and have an idea how exactly it is simulating, and then we again figure it out what exactly happening here. Okay, so that is sets. Okay, now remove the all the old values. Okay, so that is not required, so we remove that part. Okay, then set to zone, so let's do that. So what we did is override the cylinder cell 1 and 2, then we have already there top bottom part, so we did that. Okay, then remove all the sets that is not required from there. Okay, so now it is ready to run, so let first run it. Okay, and have an idea what exactly happening here. Okay, so let me open the another terminal, OF30X. Okay, and just check what is happening here. Wait a minute, let it run for few more moments. Why it is failing? Okay, so it is failing because we use the FE of solver, but I try to look at with the help of the other version, so that's why it's failing. Any problem. Okay, so now let's try to look at how exactly this. Okay, fine. So here is the cylinder, and look, this cylinder is oscillating with different intensity and the amplitude. So that is the idea. Okay, and there is incoming flows. Okay, so it is oscillating, and but please observe few things. Let's start from here. Okay, so when it oscillating, what it not shrinking the layers, it try to deleting the layers. Okay, and then when it again come back, it try to add the layers. Okay, so that is what exactly it is happening. Okay, so we are adding the layers and removing the layers based on this top and bottom patch. That is what we mention here. Okay, so based on the top cylinder layer and the bottom cylinder layer, we are adding and removing the layers for that particular files. Okay, so that is what we did here. So we try to add up the few things, okay, and try to simulate couple of entries with the help of that. Okay, so I suggest please try to run this case. Okay, it is motion wise at a time we able to specify the multiple motions, oscillatory motion on this cylinder. If you want, you can construct the your own test case where let's have a very long domain. One cylinder is adapt here, another in the wake zone. Try to rotate one cylinder clockwise, another anti-clockwise, and try to see what exactly happening with the help of that. So you can combine the different class of the motion, okay, and have an idea what exactly happening when the mesh motion is triggered with the help of these dynamic mesh options. Okay, now let's look at the last tutorial that I want to show you. It is about the inkjet type of the test case. Okay, so let's quickly try to explore that one tutorial, and we are set with the our all dynamic aspect mesh motion aspect of dynamic part. Okay, so this is what we just now look at. Now just look at another very nice tutorial very quickly. Okay, so for that let's first create the environment. Okay, so go to the folder. We're going to use the FE4 only. Okay, and what we required, let's generate the, okay, before that clean the case. Okay, block mesh, paraform, how it look like, just check. Okay, so this is the very simple mesh. Okay, what we're going to do, but this patch we try to oscillate in the x direction. That is what we're going to do, and this is all the moving walls. Okay, that walls is moving. Okay, so that is and anyway this is moving or fixed, it doesn't matter, because the entire mesh we're going to oscillate in the one particular direction. So if you look at here, you have a both has a fixed value. Okay, and we didn't specify any other things at this locations, but how we are setting is setting with the help of this dynamic mesh files, and we're going to use the dynamic inkjet mesh motions. Okay, and we are specifying the amplitude, frequency, okay, and we say reflection point equal to 0. That means this point. Okay, so this is the reflection point. Okay, up to here it try to oscillate. Okay, if you want, then you can change that point equal to some different value. Okay, so let first run as it is and try to have an idea how what exactly happening with the help of that. Okay, so let's run the test case. Okay, so run with, let's say, icodynamic form. Okay, I think something like 10 seconds or so it's supposed to run. Yeah, now just check what exactly happened. Okay, so this is the mesh, and this mesh is oscillating. Okay, so now our reflection point is here. Okay, so let's try to change the reflection point and have an idea what exactly happened. So this is very simple piston cylinder class of oscillation. If you want to define, you can quickly look at with the help of this very simple tutorial. One can construct very complicated one with the help of this very simplified tutorial, but let me just check the reflection point and have an idea what exactly happening. If I change the reflection point in place of 0, let's 1 minute, first check the mesh file, and accordingly we set the reflection point. Okay, so let's say 0.5. okay, halfway, minus 0.05, so minus 0.05. okay, that is what we are fixing the reflection point. Okay, and let's see. look, it now not going to oscillate more than 0.3. Okay, it going to oscillate till the 0.3 0.5 only. Not this boundary is not going to go further than 0.5. Okay, so that is the idea. Let's reduce further to something like, let's say 0.2. Let's see what going to happen with that. Okay, let me delete again all the files. Okay, so sorry, it not reflecting what I'm telling to you. Okay, but reflection point, try to restrict the mesh motions. Okay, so that is what my impression. Okay, maybe you have a multiple domain. Okay, at that point of time is supposed to work. What I mean, let's say you have another domain attached. Okay, at that point of time we said that within that particular one domain it's supposed to oscillate. At that point of time this value may control the oscillations. Okay, so sorry, I have impression that it's supposed to also work on the single domain as well, but whatever I'm thinking, it not reflecting in the similar line. Okay, that means when we have multiple domain, and if we want to restrict, let's say up to that point only, the mesh motion supposed to affected at that point of time, this value going to restrict up to that level. Okay, so but with the help of this very simple test case, you able to mimic the piston cylinder class of the motions. Okay, so let me summarize everything what we learned in this dynamic mesh motion class of the sessions. Okay, so here we have a couple of options. Either we go with the FE4, that is the extended version, or we go with the release version. Okay, so when you are working with the FE4, I explicitly giving the different folders. Okay, so you need not to worry about that part. If it is folder is FE4, that means you have to source the extended version. If it is OF30X, that means you have to source the release version, and you go ahead and look at the test cases. Okay, and here I gave very interesting test case. Okay, but here you have to create your own motions with the help of the some class of the coding. Okay, so if you are interested, please look at it, because this is very different way to take into account the different class of the motions. So it is the standard tutorial available. I just kept it here for your record. Okay, if you are interested, then explore how you can specify the mesh motion with the help of the different coding as well. Okay, so try to explore this tutorial as well. If you are interested to generate your own different class of the motions, then this particular tutorial going to help you, and for that you have to compile that particular source code. Okay, so that is what I here mentioned, compile library RBF motion functions, and that is you supposed to do, and then you run the test case. Okay, so this give you the different idea, like you can customize your own mesh motions with the help of the different class of the equation as well. Okay, so that is what this one last tutorial is reflecting. Okay, so if you are interested in developing your own new mesh motion, then this is give you the little bit idea. Otherwise we have a very different class of the mesh motion that we covered with the help of variety of the tutorials. Okay, so I suggest please go through it and try to create your own tutorials, and that is the way to learn it. Okay, so you practice it and try to add up some literature and try to generate your own test cases and run it and try to compare it. Okay, so that is how one can add up the dynamic mesh motions.